In this video, I will provide you with the angles that you can use to lay out and build winder stairs. So let's go ahead and get started with the first one, where we have a line connecting at both ends of a square and is a 45-degree angle. So one step in the landing. 3 steps will have a 30-degree angle. So each step from this point here, 30 degrees, from this point here, 30 degrees, and then 30 degrees. And of course, that would be coming from the center point here. Next up, for our winders with 4 steps in a square for our landing, we're going to have 22.5-degree angles. And since 22.5 is half of 45, you can again draw the straight line down the middle for your square. A square, of course, is going to have the same measurements on each side. And in our examples here, we're using 4 foot. And even though I'm providing you with the angles for these winder stairs, you will need to check with your local building department to verify whether or not you can build them, especially this one and the next one, where the steps are extremely narrow and might be unsafe to use. Where the steps are extremely narrow and could be difficult to use. And for our last example, a 5-step winder stairway will have an 18-degree angle. And again, that will be from the center point. In this video, I will show you how you can use tape to lay out the lines for your grippable hand railing. And you might not need it for a situation like this, or a situation like this up here, but you might need it when you get to an area like this that you might not be familiar with. And I actually got the idea from someone who suggested that you can use a string for this. So if that will work, then try that also. And I think the best way to go about it would be to cut a board at the desired length you're looking for either the bottom or the top of your hand railing. And then get the board in the plumb position so that you can figure out where to place the tape. And of course, the reason why you're using the tape is so that you don't put any pencil marks on the walls. And you can put as much tape as you feel like you need on the walls. If 2 or 3 pieces is going to work better than something like this, then go for it. Just make sure that you are using painter's tape, something that is not going to peel the paint and your texture off of the walls when you go to remove it. And since the key positioning points are going to be from the front of the steps or the corner of your landings to create a continuous handrail, then you're simply going to position them something like this. So again, here we have the front of the step. We're plumbing our board to create a vertical line and positioning the tape where we need it so that we can basically connect the dots to create our handrail layout lines. But I'm going to go ahead and remove these layout lines because this isn't what we're going to have. We're going to have something that looks like this. Then we're going to create our layout lines by simply connecting the dots with more tape. And that's the beauty of this. If you don't like the design, you can simply reposition the tape. And if the line you laid out was for the top of the handrail and you needed the line for the bottom of the handrail, then you could simply lower the lines and reposition the tape for that also. And again, the complicated areas, something like this that might be a little confusing for you. Or you might want to put a curve here instead of having it miter in at a corner. Or you might need to move this a little further forward or a little further backwards, or you might need to extend this a little further down. And for a situation like this, you could just simply run this tape all the way down and then do some measuring to see if that would work. Instead of having a 90-degree angle here, you might be able to run the hand railing and connect it with a miter joint here. And of course, if we have a winder set of stairs or a curved set of stairs, for example, if we add a step to the landing, then we're going to create another situation for the handrail that we might not be familiar with. And that's where using the tape really comes in handy. It provides you with a visual idea of what the handrail should look like, and in some cases will provide you with an excellent way to locate all of the hand railing hardware that you're going to use to attach the handrail to the wall framing. In this video, I will provide you with another project that you might be able to build without a lot of complicated math or calculations. And we're simply going to have a deck with 3 steps. And the beauty of this is that you're going to be able to use 2x6 or 2x8. However, with this design, we might have a problem with the building code that requires a 4-inch sphere or a round ball to not be allowed to travel through any part of the stairway. And we're going to be at 4 inches here. If I have a 2x6 and then I put an 1.5 inch thick decking board on top of that, I'm going to be right at 4 inches. And if I use 2x8 for something like this, I'm going to be over 4 inches. And I'm also creating this design here to sit on top of soil. And I'm not about to suggest that these bottom boards won't rot. And I will leave it up to you if you need to make further modifications to this to meet local building codes or work in your area. Another good thing about this design is that we are not going to have any mitered corners. Everything is going to be a 90-degree angle. And that's going to make this project a lot easier to build also. And to calculate the lengths of the boards we're going to use for the smaller stringers, all we need to do is draw a straight line down here and then measure each one of the boards from that straight line. And that's going to give us the length of each board for these smaller stringers. So in other words, this board right here will be the same length as this board. This board here going back to the line will be the same as this one here. And I know that might seem confusing, but let's go ahead and motor on and continue with our tour here. Don't forget you can stop the video at any time. And of course, watch the video again if you miss something or if something isn't quite making sense. And don't forget that you can modify this design, like I mentioned earlier, by installing additional bracing, blocking, and structural supports. And you can connect each one of the 2x6s together with building hardware like straps or flat framing anchors, even blocks. Just make sure that you install some of these framing anchors on each side. If I was just going to install all of these framing anchors on this side, along with the straps, then it might allow the 2x6s to fold over at the breaks or where the 2x6s are going to be connecting to the other 2x6s. So we're going to need to install some type of support bracing on both sides. And another idea might be to use a block. And if you put the block in between 2 boards here and then attach it with screws or nails, something like this here on both sides, then you might be able to use that instead of something like this. And you might even be able to use dowels to fasten these together. And don't forget to check out other types of framing hardware that you can use to create stronger stair stringers. And to figure out this length here, we're simply going to lay out some of our decking boards until we get the desired width that we want. If you want to cut one of these in half or cut it down to create a specific shape, then go ahead and do that. I'm not doing that. This deck, to meet most building codes, needs to be 36 inches long or 36 inches wide here. And to get that, I think 36 inches is right about here. I made it a little bit longer. You can't make it shorter, but you can make it longer. And if we use this method here, we're going to be able to create a deck that doesn't have shorter boards in it. Our deck's going to look nicer, at least in my opinion. And we're going to do the same thing with our stair steps. 2 steps with a 2x6 is going to give us about an 11-inch wide step. And it's going to be important to keep all of our stair steps the same width or depth going in both directions. So if you can see here, we're just simply raising this step up here. And I'm going to do the same thing with this step here. And finally with our last step here. If you notice, I've created a flat section here. And we're going to use each section here to calculate the lengths of our decking and stringer boards. And this is the beauty of this right here. This really makes your job easy. And make sure that you figure out the width and the depth of the deck before you get started. So in other words, you might not need to cut any of these boards. For example, if I had 10-foot 2x6, I could lay the 10-foot 2x6 next to each other, put the desired gap in between each board if I'm going to have a gap in between each board, and then grab my measuring tape and measure the distance. And if I want to make this distance here the same as this distance here, so that both the width and the length or the depth of the deck will be the same size, then I can do that. And it wouldn't be that difficult to lay out your boards in this direction here with the desired gaps if you're going to have them, and have them run full length to get these measurements here. So the measurement for this board right here is going to be the measurement from right here to right here. The measurement for this board right here, this step, this 2x6, the second one down, is going to be measured from right here to right here. And this board here is going to be the measurement from the front of this right here all the way to the back. And you guessed it, this measurement here all the way from this point to this point is going to be the measurement of our bottom board. And now would be a good time to point out that the bottom board will need to be ripped down and made a little bit shorter. What you're going to do is take the height of the decking. 2x6, we're going to have 1.5 inches thick 2x6. We're going to subtract 1.5 inches off of the bottom board. So if we have a 5.5 inch wide 2x6, we're going to rip that down to where it's 4 inches wide. And that's going to allow you to make each riser height the same size. So again, these lower boards, all of them are going to be 1.5 inches shorter if we're using 1.5 inch decking. If I'm using 2-inch thick decking, then I'm going to subtract 2 inches off of my 2x6. And I won't be going into a lot of detail about that in this video. However, I do have plenty of other videos at our website. Make sure you check them out if that doesn't make sense. And in our design here, these are not going to be the same size because the width of this is shorter than the length. And you can see it right here. If I wanted to make this length here the same as this length here, then I would need to cut these boards a little shorter. For example, if I have 3 foot 3 1/4 inches as a measurement from here to here, I've figured out how many decking boards I'm going to need according to my local building code. Got to be bigger than 3 foot. Then the same is going to hold true for the width. I could simply cut these boards here 3 foot 3 1/4 inches to create a square landing, or a landing with the same measurement for the width as it would be for the depth. And that's going to change the measurement of some of our boards. And I could always make this 4 foot wide and this 4 foot long also, if it's going to work with our decking. And hopefully that makes sense. However, if it does not make sense, then feel free to let us know in the video comment area any questions you have about this, or if there was something I didn't mention, or if you have a better way, then feel free to share that with us in the video comment area. Here is another quick tip for those of you who are cutting your stair stringers and a section of the stair stringer breaks off of your $40 or $50 piece of lumber and you're not that hip on getting rid of it. And you don't have to. Simply put some adhesive on both sides that need to connect together, place it back on, then grab some small nails and reattach the broken tip back to the stair stringer. And I've done this hundreds of times with great success. And of course, you're probably not going to have this problem if you're selecting primo lumber, number 1 or a select grade of lumber for your stair stringers. However, there are a variety of other circumstances that could lead to this. And if you can save the lumber using this trick, then definitely use it. In this video, I'm going to point out a suggestion for a handrail for this type of stairway. This is basically something that one of our viewers was having a problem with, and basically creating a doorstop for the door. So if I zoom in, I think I got a picture of it here. You can see right here, there's a spot on the door that is hitting the handrail. It's basically acting as a doorstop. And I can see right here that the door isn't going to fully open. It's never going to fully open again because somebody put the handrail in the way. And I see stuff like this all the time, and I'm not about to suggest that it's inexperience. Because of local zoning or property line measurements, building can't come out any farther. Then you wouldn't be able to extend the wall and then just have a straight handrail here. However, if you could extend the wall, you could extend it on both sides or extend it and then use this method here for your handrail. And of course, at the top of the stairway like this, we're going to have a landing and a door entrance into the building, along with an easier way to create a safer handrailing system. Something that's going to be easier to install, easier to build, and easier for the people who use the stairway to use. And if you don't like that idea, you could always install something like this. Remember, most of the time we only need a grippable handrail on one side of the stairway. And if you remember in the picture before, the handrail came down over here. Who's going to walk up the edge here and fumble around with the steps right here and then turn and walk up? And I get it, if you have to, you still have a safety problem right here. You don't have a safe place for someone to turn and walk up the stairway. Where with this situation right here, you're just simply going to start here and walk up the stairway. And if you need to direct traffic, you don't want people coming up this side here, then you could always install some type of an obstacle, plants, potted plants, or something that might even be installed permanently that you won't be able to move for the purpose of redirecting traffic more towards the center of the stairway and try to avoid the sections of the stairway that might not be safe. And this probably won't need a guardrail on each side because we're not over 30 inches in height. However, you would need to check with your local building department to verify whether or not you could use any of these methods I mentioned in this video. Here is another thing you can do when you are building stairs, and you would actually like them to turn out as nice as they possibly can. And that would be to stack your stair stringers on top of each other before they're installed so that you can check for any imperfections. And to do that, you're either going to line the back of it up, you're going to line the front of it up. Because if your imperfections are only about 1/16 of an inch, then I wouldn't even worry about it. What you're going to be looking for will be imperfections that are going to be a little bit larger. So here you can see where everything looks good, and you've done a good job cutting your stringers at the top. And again, if this was off just a little bit at either the bottom or the top, then you can probably let it go. However, if it's off quite a bit, then you're going to need to make some adjustments to it. Or at least I would recommend that you make some adjustments to it. And you can do that by adding shims or shaped strips of lumber like we did here. And I would recommend using some type of an adhesive along with some small nails or screws to attach the shim to the stringers. And I will be making a future video to show you what happens if you don't fix this before you install your stair stringers. So here we had some imperfections that needed to be filled, and we used shims to do that. However, you could end up with an imperfection like this that needs to be trimmed. And if that happens, just simply grab your saw and recut that part of the stringer, or use a planer or some type of a sanding device to trim the wood off. Now, I've also used belt sanders to flatten some of these imperfections out also. And the last thing I would like to suggest would be that if you have too many imperfections, then you might consider recutting the stair stringers. In this video, I will provide you with a couple of methods you might be able to use to repair a bracket type stairway where the bracket might be loose because part of the stair stringer is rotted. And this could be from termites or dry rot, some type of moisture problem, or even the fact that the stairway hasn't been maintained or painted and sealed properly. And keep in mind that some of these methods can be used for more than one bracket. And of course, if the damage is beyond repair, make sure that you replace the stringer. So let's go ahead and start with our first suggestion, and that will be using a larger bracket. You could make your own bracket or purchase something that you might be able to use to where you can relocate the lag screws or bolts, whatever you're going to use, to reattach the bracket to the wood stair stringer. Another method that might work for you would be to install some type of additional lumber. And this could be a 1x4, a 2x4, 2x6, or anything else that would allow you to reattach the bracket to the wood stair stringer. And I realize some of you are worried about covering the wood rot, and I don't blame you, or termite damage, and I'm here to tell you that I'm going to have to leave that up to you, because sometimes when you cover wood rot and you don't treat it or seal it somehow or remove all of the wood rot you possibly can, it could still remain a problem. The wood rot could get worse. Same with the termite damage. And again, something to think about. Next up on the list would be to use a larger piece of lumber. Again, this could be a 2x12 or 2x14, and it can be shaped to fit the stair stringer and even beveled up here, as you will see in the next example. And you could always install some type of an adhesive in between your new board and the stringer. And yes, you could use treated lumber if that's going to work for you. Just make sure that this gap right here is sealed and maintained, because if there are any cracks or gaps there, you're going to allow moisture to get in between the two pieces of lumber. And again, that could accelerate the process. And for those of you wondering why I'm even showing this, it's because I've seen people use these types of repairs incorrectly and on stringers that should have been replaced in the first place, instead of doing any repairs like I'm suggesting in the video. And in our final method, you might choose to drill some holes all the way through the stringers to reattach the brackets to. And keep in mind that this method here might work just as good without this board, depending upon how much damage you have to the stringer. And of course, the bevel I was referring to, a bevel like this could prevent someone's shoelaces or parts of their clothing from snagging here. And this could also be a problem for other repairs I've already suggested. You might want to bevel or round off the corners on some of these pieces to prevent any type of safety problems. And another thing you're going to need to do will be to reduce the length of the stair tread by the amount of lumber that you've added to the stringer. And in our example here, that would be 3/4 of an inch. And the last thing I want to mention will be that you might need to check with your local building department to find out what the minimum width of your set of stairs is, to make sure that you're not making it smaller than that. And most of the time on residential stairs, that will be 36 inches. Here is another problem that some of our newer stair builders are having at our channel, and that's figuring out the starting points and stopping points for the stairway. And even though this rarely happens, you're rarely going to end up with a problem at the top of the stairway. The problem's usually going to be at the bottom of the stairway if you do not calculate the measurements accurately for the individual riser height and tread depth, because you don't know where the stairs are going to stop vertically and horizontally. And here's an example of what I'm talking about, where we have a low riser at the bottom or a taller riser at the bottom, because we didn't know what the finished grade was going to look like. And I'm not about to suggest that you can't solve this problem by regrading the property or by installing new hard surfaces like a concrete sidewalk or by adding more soil to your property. Then you should create some type of a design plan to where you know exactly where the bottom of the stairway will need to stop, the vertical height and the horizontal height, along with the vertical and horizontal height of the upper section of the stairway where it needs to start or stop, to prevent spending unnecessary money on a problem that could have been solved by simply creating some type of a design plan before building your set of stairs. In this video, I am going to try and help one of our viewers who is having a difficult time figuring out if the riser, the last riser at the top of a landing, can be taller or shorter because it's going to the landing, and it cannot be. And even though I did another video on it, I might not have been clear, or should I say crystal clear, but this is actually a flight of stairs. And within a flight of stairs, all of the risers and treads should be the same sizes. However, most building codes allow there to be a maximum variation of 3/8 of an inch. And I'm not going to go into a lot of detail on that. I do have another video on that at our website in the building codes section. So the stairways between the floors and the landings or the platforms in this example are a continuous flight of stairs and should be treated that way. However, when we step up from a floor or a platform or a landing up to another floor, landing, or platform, and then go up our set of stairs, it might be a little different. You could actually view this right here as a flight of stairs and separate from this stairway. And if you're having problems with this, you're having problems with a building inspector, feel free to show them this video. However, keep in mind, they are going to have the final say on this, and not me. I'm just simply providing you with an interpretation of the building codes, and their interpretation might be different. Now, if I have a winder step in the landing, then this would be a step and this would be a step. This is not going to be considered a landing unless it meets the specifications for a landing according to your building codes. And in this example here, this would be part of the flight of stairs. And each one of these risers would need to have the same riser height as this flight of stairs here. However, that wouldn't be the case here, where we have a landing stepping up to another landing. So again, this would be considered a flight of stairs. This would be considered a flight of stairs. And then this would be considered a separate flight of stairs. And again, I can't stress this enough. It's going to be up to your local building department to provide you with clarification and their interpretation of their building codes. And hopefully this makes sense. However, if it does not, feel free to leave your questions in the comment area, and I will answer them as soon as possible. Here is a helpful video for anyone who is planning on designing some type of crazy landscaping design in their backyard, where you might be using a variety of different rocks or other building materials that might make your stairway look like it's more of a part of nature than man-made. And I'm here to tell you that out of the 4 of these designs, this is the only one that is going to meet with most of your local building codes. And for those of you who think that your building codes only apply inside the house or maybe in your front yard and not your backyard, well, think again. And I would also like to point out that irregular shaped treads or steps like we have here and here not only might not meet your local building codes, but they're going to make it difficult for people to walk up and down. How do I know? Because I've been walking up and down stairs for a long time, and I've also observed plenty of other people walking up and down a set of stairs. And even a stairway like this isn't always going to be as easy as you might think for someone else to walk up and down. So why do we want to make it more difficult for someone to walk up and down by making wider steps that aren't the same size as the other steps, or by creating some type of an irregular shaped tread, or making matters even worse by not just having an irregular shaped tread, but irregular or different sized risers to make it even more difficult for someone to walk up and down the stairway. And I get it, if you have to do it, you've got to do it, knock yourself out, or at the very least, install a couple of handrails for people to hold on to while they're using your work of art that was built by nature and not man. Here is another quick tip I would like to throw out there for stair builders who are looking for a little stronger connection at the top up here, where the last tread can be used to prevent the stair stringers from separating from the ledger. Now, obviously, this is a little extreme here, so let's go ahead and put that thing back together. And this is normally how it's done. We're going to nail the treads to the stringers. However, if we nail the tread to the ledger, we're going to create a stronger connection point between the stringer and the ledger. We're basically going to use the tread to make that connection stronger by simply attaching it to the ledger. And for those of you who want to even make it a little stronger, then cut the tread a little larger so that we're not going to be nailing at the edge of the ledger. And in this example here, we are using 3/4 inch OSB. And you can see here where the nails are going to be centered in the ledger a little better instead of on the edge. And to do this, all we need to do is have the tread go back a little further and have the riser sit on top of it. Because as someone who has built a lot of stairs in their career, I can tell you that this particular tip right here isn't going to cost you that much more money to create a stronger connection at the top of your stairway. Here is another helpful tip for anyone who is building, repairing, or remodeling a stairway that uses metal brackets to connect the treads to the stringers and would like to relocate the treads either a little farther forward or a little further backwards. And the first thing I want to point out is that the riser height will not be affected at all by moving the treads forward or backwards. And for the most part, by moving the treads forward or backward, you're not going to affect the bottom distance between the front of this tread and the front of this tread. Or in other words, the measurement that is going to be measured by the building inspector. And I do have other videos on that in our stair building code area at the website if you're looking for more information on how to calculate that measurement. However, at the top of the stairway, you're going to have a problem unless the floor, landing, or deck framing is done incorrectly. So in our example here where everything is done correctly, we have an 11-inch measurement between the front of the step and the front of the floor framing. And at the bottom, we have the same thing. We've got 11 inches between the front of the step here, back here, and the front of the step above it. And if you notice the distance right here, we're going to go ahead and change it. We're going to move each one of the steps 2 inches forward. And for those of you who guessed it, at the top, we're going to have a 2-inch gap now between the back of the tread and the floor framing. However, like I said, the riser height wouldn't have changed on this, but the length of the last tread is now 2 inches longer. We have a 13-inch long step at the top. And to fix this, we're going to need to add a filler board to the back of the tread and extend the length of the floor framing by 2 inches. Now, this is one way to fix this. You can add or subtract materials at the top to compensate for whether you're moving the treads forward or backwards. Or we can remove some of the material from the stair stringers. If I take 2 inches off of both sides of the stair stringers, I can shove the entire stairway forward, go back to the original framing, and everything will work out just fine. And if you notice, I drew this line here. This is the same line I drew in our first example and kept it there as a reference point so you can kind of give a better idea of what we're doing. And hopefully this makes sense. However, if it does not, feel free to leave any questions you have about it in the comment area, and I will answer them as soon as possible. Here is another question that I have received quite often, and people want to know, where do the tread sizes come from? And for the most part, they're going to come from your local building code books or local building department officials who can provide you with the minimum sizes for your stair steps. And this is going to be the width and the depth. And again, I said minimum sizes. These minimum sizes will be anywhere from 9 to 10 to 11 inches, depending upon what project you're going to be working on, or whether or not it's going to be for commercial, industrial, public, or private residential home use. And then once you have those measurements, you can go ahead and lay your stairway out on the ground. And that might look something like this when you're done. You might have a landing and then 5 steps. And if the minimum building code requirement is 10 inches, then something like this might work. And keep in mind that even though the depth of each one of the steps is the same, this stairway has 6-inch riser heights going all the way down. This one here has 8 inches. And again, this will be another thing you're going to want to check with your local building department. And I wouldn't be surprised in the future if they change these numbers also. And like I said, you're going to be better off if you don't know a lot about stair building. And that will be to lay out the basic design of the stairway on the ground or on your building foundation floor or even on a sheet of plywood, something that will provide you with a design of the stairway that can be used to pull measurements from if needed to build your stairway. So again, check with your local building department to find out the minimum and maximum sizes for your treads and risers, along with the minimum width of the stairway before building your stairway. Here is another video that one of our viewers requested. And even though I won't be going into all of the details here, I'm not going to be breaking out the pry bars or the sledgehammers and the chainsaws. However, I will be providing you with very basic instructions on how you can take apart most stairways. And that's going to be by simply reversing the assembly process. So let's go ahead and get started by removing each one of the stair steps. And even though I do not suggest that you stand on any part of the stairway that you are removing, I have done it before, but I know what I'm doing. So this process right here, where we're taking apart the stairway from the top, might not work for you. And you might want to take the stairway apart from the bottom so that you won't be standing on it during any time of the demolition. And of course, that would look something like this here. And another thing I would like to point out is that you can remove the center stringers before removing the outside stringers to give you room in here to walk around. And this will definitely be beneficial if the stringers are attached to the wall framing on both sides. And even though I won't be providing you with examples on how to do it, you can always use a saw to cut the stairway components into smaller sections. For example, if this stair stringer is attached to a wall, I might want to grab a circular saw and cut it into smaller sections to make it easier to remove from the wall. And don't forget that prying something, if I grab a pry bar and I get it behind the stringer and I'm trying to pry it away from a wall that I don't want to ruin, it's drywalled on the other side or it might have tile on it, then you won't want to use a pry bar because you could damage the wall finish on the other side. And this is where cutting it into smaller sections will benefit you. So remove the inner stringers if that's going to work for you, or the outer stringers first if that's going to work better for you. And if you have a stairway with risers, then you're just simply going to start from the bottom by removing either the tread first or the riser first. So in this example here, we remove the tread first. So tread, then riser, or riser, then tread, whatever's going to work easier for you. And of course, you could always remove all of the treads first and then all of the risers second. And yes, even though it's hard to believe, it wouldn't be a bad idea to create some type of a plan to demolition your stairway. And the last suggestion I would like to make is to be safe, something that people say yet might have a difficult time understanding. So you might consider hiring a professional if you're not comfortable or some of the information in this video doesn't make sense. One of the biggest problems do-it-yourselfers are going to face, and even people who haven't built a lot of stairs, will be to deal with the imperfections in the floor, if there are any, the connection at the top for the stair stringers, and the biggest problem of all is going to be whether or not all of the stair stringers were cut exactly the same. And the best way to figure that out will be to grab a straight edge, usually a level, and place it on top of the stair stringers like we have here. And if there aren't any gaps at all in between the straight edge and the stair stringers, then you have created a nice straight step. And this is ideally what you're shooting for when building a set of stairs. So check everything you possibly can to verify, especially the steps, to build the perfect stairway. So we're going to check in 5 locations: the back, the front, the middle, and the risers can be checked at the top and the bottom. And you can check them also at the middle if you feel like you need to. And again, we're going to be looking for any gaps at all between the stringer and the straight edge. And of course, one of those gaps might look something like this, and you could simply add a filler shim to fix something like this. And you could simply add a shim there to fix something like this. And I think anything around 1/8 of an inch or less, you can probably leave alone. And quite possibly on a riser, even 1/4 of an inch might be okay, depending upon how much of a perfectionist you are. However, 1/4 of an inch for the steps is going to be too much, and you're going to feel it when you use the stairs. And again, I think 1/8 of an inch might be okay for something like this, but I'm going to leave it up to you, because most of the stairs I built, I could check this with a level and within a few minutes fix most of the imperfections, because they were usually going to be in the floor or at the top of the stairway where the stringers connect to the upper floor. And if that was the case, I could usually drive some wedges or shims underneath the stringer that was a little low to make the adjustments that I needed. And if you need a little more information on this, let us know in the comment area, and I'll make another video on most of the problems I dealt with when dealing with situations like this. Here is another question from one of our viewers. They wanted to know how you could raise the risers on a stairway. And I'm guessing that you would be raising the risers if you raised a deck, porch, landing, or floor. And if you did that, then you could add materials to the top of each step. However, you will not be able to add the same thickness to each step. For example, in this situation here, we raised the platform 7 inches and we have 7 risers. However, we will not be able to just simply add 1 inch to each one of the steps to solve this problem, because all that's going to do is make a difference at the top and the bottom. It won't make any difference at all to all of the steps in between. So to solve this problem here, we're going to need to increase the increments of each step by the difference between the existing riser and the new riser height. And to do that, you can simply measure each one of the existing risers. And if they're the same size, great. If not, maybe grab a piece of paper and write down the individual height of each step, or the riser height for each step, and then divide the overall height that you've added to a new floor. For example, we have 7 risers. We've added 7 inches. And if I divide 7 into 7, I'm going to get 1 inch. And that's the amount we're going to add to each step. So 1 inch at the bottom, 2 inches on the next one, 3 inches on the one after that, and then 4 inches, and then of course 5 inches and 6 inches. And in this video, I'm not going to go over how you're going to add the materials, because I have plenty of videos on that. Check out our riser variation videos. And don't forget that you can always remove the existing stairway and replace it with another stairway if adding materials like this won't work for your project. In this video, I will provide you with an easy way to calculate and figure out whether or not you can use pre-cut stringers for your project, or whether or not you're going to need to lay them out yourself to make them work for your project. And don't forget that I do have books on laying out stair stringers and building straight stairs at our website. Now, the first thing you're going to need to do will be to measure the length and height of your stairway, because we're going to need these numbers here to calculate the riser height and the tread depth. And the tread depth won't be a problem if the stairs don't need to stop at a specific point. However, the risers will. This is going to be the big problem here. And if you actually want each riser heights to be the same size, there's a very good chance you're not going to be able to use the pre-cut stringers unless you build the deck or floor to match the height for the pre-cut stair stringers. So that covers the risers. The next thing we need to do is think about the steps if they need to stop at a particular point. And this is going to be common in new home construction or remodeling. Another thing we need to consider is local building codes that might require you to have a 10-inch or an 11-inch minimum step and a maximum height for a riser of no more than 7 3/4 inches. However, you would have to check with your local building department in your area to verify this information. And yes, this might seem a little silly, but I've seen it before. When someone who doesn't really know what they're doing needs to make the stairway stop at a particular point using pre-cut stair stringers. And yes, it works both ways, either having a small step at the bottom or a smaller step at the top, or a larger step at the bottom, or a larger step at the top. And the same holds true for the risers. I've seen stairways built with prefabricated stringers that have taller stair steps on the bottom, smaller stair steps on the bottom, and the same up here. Or you could even end up with both a small riser or a tall riser, a small riser and a small riser, or even a combination of something I can't even imagine because somebody thought that a pre-cut stair stringer was going to work for their project, when in fact it did not. So you can always buy one stair stringer and then put it into a position that you think will work, and then break the level out and make sure that the steps are level and that all of the tread measurements will be the same and that all of the riser measurements will be the same. That's one way you can do it. Or if you're starting out with something like this, where you have specific measurements you need to work with, then you can simply start dividing a few numbers until you arrive at the length of your individual treads and the height of your individual risers. So let's go ahead and break out our calculator, and we have 3 foot 7.5 inches, and we're going to convert that to inches. So 12 times 3, that's 3 feet, equals 36 inches, plus 7.5 equals 43.5. And we can just divide this number by 7. I'm going to divide it by 7, and that's going to come out with 6.2. Now this is going to tell me that I'm either going to have 6 or 7 risers that will be around 7 inches tall for our stairway. So let's go ahead, clear this, and go back to 43.5. We're going to divide that by 6, and that's going to provide us with 6 7.25-inch risers. And you could always try dividing the next number lower or higher into the overall total rise to see what numbers you get for the individual riser. You might want to use one of those numbers instead. And now that you have the individual riser height, you can go down to your local home improvement center or lumber yard and see if they have a stair stringer that has at least 5 steps and your exact riser height or tread depth that you've calculated. And now for the bad news, if it does not, and it has 7-inch risers, or it's not going to have enough steps, then you're not going to be able to use it. However, you will be able to use it if it has more steps than you need, because you could always cut one of the steps off. And hopefully that makes sense. If not, rewatch the video or go check out some of our other videos on our website. I have plenty of videos on our website showing you how to calculate the individual riser height, tread depths, how to use a framing square to lay out a stair stringer, and like I mentioned earlier, even books that will help you build a variety of different stairways. Here's a quick tip for anyone who is looking for extreme accuracy when building a set of stairs, and that will be to avoid using this part of the tape measure to create an accurate measurement. Instead, add an inch to the measurement. So I was trying to get a 5.5-inch measurement, move it back an inch, go to 6.5 inches, and then go to the 1-inch mark on the tape measure to make your mark. And you can see here where we have 5.5 inches. However, if I go back here, you can see where the tape measure is a little bit off. It's almost a 1/16 of an inch off if I'm holding the edge of the tape, which is often loose, and loose for a couple of reasons. I'm not going to go into the details on that, the reasons why the edge of the tape measure or the tongue is going to be off a little bit. So again, just simply add an inch. You can add 1/4 of an inch or a 1/2 inch, but it's usually easier for me to add an inch and then go to the 1 inch mark on the tape measure. And I'll even use this method here when checking my treads and risers, when setting up my framing square, or for other measurements that I need to be within a 32nd of an inch of. Here is another thing that I see stair builders doing that might not be necessary, and that would be adding more stringers or doubling up the stair stringers. And keep in mind that I will not be able to tell you whether or not you need to do this, but I can tell you that I see it plenty of times on the exterior of a building, and if it is, then you could end up with a water trap. And this would be a small gap that would allow water to get trapped in between the lumber. And I'm sure some of you have seen videos where you can put some type of a waterproof membrane on top of the double stringers. But that can also lead to a problem. So my suggestion would be to maybe add 1 or 2 washers in between the stringers and then go ahead and run a bolt through them if you're looking for a stronger stringer. Something like this is going to allow the water to drain out of the area in between the stringers. Or instead of doubling up the stringers, you can just simply lay them out a little different. However, something like this might require a few more nails and could make it difficult to create a straight line between the other stringers so that you don't end up with squeaking stairs. Or you can use larger lumber. You can use lumber that's going to be wider or taller. So instead of using a 2x12, you could always use a 4x12 or a 6x12. Or use a 4x14 or a 6x14, or even a single 2x14 instead of a 2x12. And if that isn't working for you, then maybe you can use larger risers or even larger treads. And I'm not about to suggest that you use any of these methods in this video without considering the ultimate option of cutting a huge, massive tree down and carving your own stairway out of a solid piece of lumber. And of course, I'm just joking, because unless you're going to be installing a stairway that needs to be structurally stronger for an industrial or commercial building, for example, then you're probably going to be better off just using the standard construction practices that have been working just fine for decades. Here is another way that you can design layout and figure out the amount of bricks you're going to need for a stairway you're going to build out of bricks. And what I would suggest doing would be to figure out the size of the stairway. Lay out the stair stringer on a sheet of plywood, or lay out the design of the stairway you're planning on building. A stairway that's going to have the exact measurements you need for the treads and the risers. And if you need more information about that, feel free to share it with us in the comment area. And I'll be glad to show you how you can lay out something like this with very little effort. Next, you're going to want to place the bricks in the position that you think they're going to work best. And make sure that you adjust for the brick grout lines, the mortar that will be placed in between the bricks. And you could always do this by cutting some scrap pieces of plywood. For example, if your grout line is going to be 3/8 of an inch, then grab some 3/8 plywood, cut it into scrap pieces to find if you're going to have any problem areas. Like right here, an area where you're going to need to cut the bricks. And basically what you're going to try to do will be to eliminate as much cuts as you possibly can, or change the dimensions of the stairway if possible. And here you can see when we set our next layer or our next rows into position, we're not lining up with the top of our tread. This corner isn't working out here. And in order to make it work, we're going to need to cut this brick here and this brick here. We might not need to cut this brick or install this brick or these bricks here, depending upon whether or not we're going to fill that area with mortar or concrete. Because most brick stairways fill all of the areas they can possibly fill without installing a brick in there to save money, or if it's going to work better for your project. Obviously, you're not going to want to cut any more bricks than you have to. So here's one example of something you can do. Another example that might work would be to change the direction of the bricks. However, you can still see where we're cutting this brick and this brick. And I'm not about to suggest you're going to need to use a full brick here. You could cut this brick in half. You could cut it into thirds. All you need is the front of it. And the same over here. So again, I'm just kind of throwing out some ideas for something that might work on your project. Now with this thing right here, all we need to do to make it work would be to simply make this step a little bit longer. However, if that won't work for your project, you're not going to be able to do it. And of course, here's an example of what the pattern would look like if you're having a difficult time figuring out what the steps and risers would look like on the stairway. Next up, let's go ahead and show you what I'm talking about here. This step is this length here. We're using this, and if we use it, we're going to need to cut a few more bricks. However, that won't be the case if we make the step just a little bit longer, or in your example, maybe a little bit shorter. And this is actually how most stairways are built out of brick. The bricks basically dictate the length or depth of the stair tread, and could be an excellent way for you to figure out how to only cut a few bricks. If we use this example here, we will be able to eliminate this row of bricks here, like we did down here, and only cut the bottom row of bricks, and hopefully no more bricks, but you might need to cut some bricks at the top depending upon how it's going to work out. And if you are going to change the depth of the steps, make sure that you adjust it on your pattern, because you can use this pattern here when building your stairway. Just simply drive some stakes into the ground, firmly secure the sheet of plywood, or cut out the stairway design that you're going to use, and then firmly secure that to the ground to make sure that it is plumb, all of your steps are level, and that all of the riser heights are the same. I think this is an excellent way to build a set of stairs for anyone who doesn't know a lot about working with bricks. And of course, the method that most masons are going to use, and that would simply be to cut this row of bricks if the step needs to be a specific depth. And the riser height won't allow you to use full bricks here. And don't forget to allow for the grout joint in the back here, maybe 3/8 of an inch. And this method here will allow you to change the riser heights. You're just simply going to be able to lower the entire step. For example, if I want to lower this 1/2 of an inch, it's just going to lower into this area here. 1 more inch, lower into the area. So the good news is I won't need to cut this row of bricks, but I will need to cut this row of bricks. And I'm not about to suggest you're going to be able to get away from cutting any bricks to build a stairway that will need to meet specific measurements for the risers and the treads. And the last thing I want to point out in the video is don't forget that you can always change the direction of the bricks here, especially if you're interested in reducing the amount of joints. You can see here where we have a lot more joints in here, and this actually looks better in my opinion. So there you have it. If you've never built a stairway out of bricks, something like this could be exactly what you need to lay out the stairway. See if it's going to work, and see how many cuts you're going to need to make before you even lay your first brick. In this video, I will provide you with the difference between a step and a landing. And to some of you, this might be obvious, but to others, it isn't. And I get it. You might come across a stairway in your area or on the internet that might have different size steps or landings. However, they might not meet your local building codes. So let's go ahead and talk about what the building codes might suggest in your area, and you would have to check with them to verify the information in this video because different areas have different building codes. And according to most building codes, in a flight of stairs, the depth of the stair tread should be the same measurement. However, it can vary from the smallest measurement to the largest measurement. This would be a maximum variation of 3/8 of an inch. And an example of that would be if the smallest measurement for each one of the stair steps in a flight of stairs is 11 inches. However, I have one that is 11 3/8 of an inch, then this might be acceptable to your building inspector. However, something like this probably won't be. And this is what I seem to run into every once in a while on the internet when looking for creative stair designs that would be approved by most building departments. So again, in a flight of stairs, we can't have more than a 3/8 of an inch variation. Maximum, unless it's a landing. And a landing, according to the International Building Code book, should have the same depth as the width, or at the very least 36 inches for a residential stairway or 44 inches for a stairway with over 50 occupants in the building. And if you do have a situation like this, it should be approved by your local building department. And here's another example that should be approved by most building departments also. And another one that should be okay would be if you had a step between landings. Again, these are not steps. These are landings that meet the minimum building code requirements for a landing. Now let's go ahead and throw a monkey wrench into this one here. This is not a landing. It does not meet the minimum building code requirements for a landing. However, this is something that might be approved by your local building department because in my opinion, this stairway seems safe. Another one that might not be approved, however, you could make the bottom a little bit wider and turn these into circular steps. And I'll give you an idea of that in the next few examples. And of course, another example of something that might be considered a landing by a lot of builders and designers. However, this might not be a landing or a step. It does not have the minimum measurement at this point here. And that would look something like this. According to most building codes, we need a minimum of 6 inches here. And if we put the 6 inches here, and this does not meet the minimum measurements for a landing, then I've got some good news for you, because now this becomes a step. And this would be another stairway that should be approved by your local building department. And believe it or not, this is the reason why I made the video, because one of our viewers was having a difficult time figuring out why this isn't a landing. I would imagine most builders would even refer to this as a landing and not a step. And again, this is not a landing because it does not have the same depth as the width. This right here should be the same length or the same measurement as the width of the stairway, or at the very least meet the minimum depth required, which should be 36 inches for residential stairs, 44 inches for other types of stairs. This is part 2 to a video that I made. I will put the name and a link to that video in the video description box. And I think I figured out a way to have both what I would like to see, which is something like this, and the design you're going to see here in a few seconds. For those of you who believe that this design right here won't work for you because somehow the stringers are going to slide forward even though they're nailed and securely fastened to some base framing plates that are securely fastened to the concrete, or base framing plates that would be securely fastened to a wood framed floor. Because either you or the architect think that this is a superior design. I cannot see it. I'm never going to see it, and I'm never going to agree to it, even though I saw saw this design on almost every set of building plans I worked with. I never used it. I never used it, my dad never used it, and there's no way I'm ever planning on using it because it just doesn't make sense, and the reasons for that can be found in the other video. For those of you who just want a brief explanation, a lot of it has to do with making this notch here and then fastening the stringers to this plate here. And in some cases I've seen a gap here, and I don't like the gaps. The gaps can cause the stringers to break. And something like this might work fine on a wood-framed floor where you can drive more fasteners through the stringers into the wood-framed floors, or even use framing hardware, where on a concrete slab, you can see where you're only going to be able to attach it to the base framing plate, not to two base framing plates like you would have seen in the previous example. So what about this design here? Is this something that might work better for you? You're going to get both of the framing plates, which is what I would like to see, plus a couple of notches that in your mind might prevent the stairs from sliding forward, even though these notches wouldn't be necessary if the stringers are securely fastened to the base framing plate. So something like this would make me happy and make those of you happy who believe that this notch right here is somehow going to work better than the very first example I provided in the video. And if that one seems like too much work, what about this one here? Install the framing plates like I would like to see them installed, and have a notch at the back of the stringer, providing us with another method that might work better than the second example in the video. You're going to be able to use two framing plates that you can use to attach the stringers securely to the foundation, and have your notch here to prevent the stairs from sliding forward, to prevent the stringers from sliding forward. If this is actually something you believe will happen, again, even though I've never seen it happen. And if you don't like that idea, what about this one here? Grab a huge piece of lumber and securely anchor it to the foundation. Don't just secure it in the front or in the back. Otherwise, you could end up with the board twisting and forcing one side of the stringer up, and that's probably not going to happen if you have enough base framing anchors to prevent that from happening. So there you have it, and as always, any questions, feel free to leave them in the comment area, and I will answer them as soon as possible. In this video, we will be talking about the 25-inch design rule, and this is simply taking two riser heights and one tread depth measurement and adding them together to see if you can be between 24 and 26 inches, or 1 inch away from 25 inches. So don't bother asking me why they don't call it the between the 24 and 26 rule for designing a comfortable stairway for most people to walk up and down. And for those of you who have watched my channel for a long time, you might have seen the 17.5-inch rule. And that would be when you add the depth of the tread to the height of the riser. And you can see here, if we do that, we have 17.5 inches. This is a comfortable stair step for most people. Here's another comfortable stair step for most people. And if we add these numbers together, we're going to get 25.5 inches. Here's another one that will add up to 24.5 inches and another comfortable stair step for most people. And for those of you wondering who most people might be, that would be the average sized person. And even though I don't have those exact heights, I would be guessing those measurements would be somewhere between 5 and 6 feet. Because this stairway is not going to be comfortable for someone who is 3 foot tall or someone who might be over 7 foot tall. And now to provide you with a few reasons why this formula isn't always going to work. And that would be if we had a situation like this. Because even though this provides us with a fairly comfortable stairway to use, it might not be as comfortable as the ones I just showed you. And definitely not as comfortable as this one here, where we have a small step and a tall riser height. So what should you do with the 25-inch rule for designing stairways? I would simply suggest using it if you have a riser height between 6 and 8 inches, or if you have a tread depth between 10 and 12 inches. And it works within the maximum and minimum building code measurements in your area, which would also fall into the category of most of the stair step measurements you're going to find on a stairway anyway. However, I wouldn't use it for a situation like this or a situation like this. A situation like this, you're going to be taking 2 steps most of the time. And even though that might be comfortable for someone who has a difficult time raising their legs up this tall, maybe an older person. And let's not forget that you can design your stairway for the people who are going to be occupying the property. Just keep in mind that if that property is ever sold, it might not work for the next owner.